Yeah, I disabled. I put the normal latency. It should be better now. Looks of a better quality too. Okay, I think I can start again. So yeah, I was talking about the power regulator, and so its purpose is to take a voltage at the input, a range of voltage usually, and output a fixed voltage which is determined by the part. Some of them have can be adjustable, but usually the 78 series they always have a fixed voltage, and so here it's 8 volt, and so yeah, it will be the component that will power the circuit with the external power supply. And yeah, I'll talk a bit long about it, but just don't mess around with it in your circuit bending, because usually it will not. You will either like burn the transistor itself, or yeah, it's better to just avoid this part, even if it's not really harmful or something. But it's mostly because since it powers the whole circuit, if you break it, the whole circuit will be dead for now. So yeah, just avoid this part. And so yeah, this is I didn't mention, but this is a audio video processor. So you got all the right part is audio, like you can you can adjust the level of the audio input and fade in, fade out. So yeah, we don't really care about this because we are doing video today. So yeah, we can just yeah, for example, oh yeah, I still have the other. Okay. So yeah, I was back. Okay. So yeah, what I was saying is so yeah, this is the device, the cover, and so you got like all the right part here is for audio, so we don't really care. And yeah, for example, those are audio op-amps, so operational amplifier. Those are like really useful component that is really used in yeah, all kind of purpose in electronic. And yeah, but yeah, we don't see any of those amplifiers here, because yeah, they are a bit costly, and yeah, since it's like a really cheap video device, yeah, they don't really they mostly did it with transistor. And so yeah, this is um, ViewMeter chip. It helps doing the ViewMeter thing. It like converts. It's a bit like a digital analog to digital converter, and yeah, with it, it's not the subject today. And so yeah, the video part is here, and so the input is around here. So yeah, we can guess that all the components here around here are used for the video. Yeah, input. Here it's the outputs, and we got like plenty of stuff here. So yeah, the most interesting chip on check it is probably this one. It's let me see if I can enough to have it. Yeah, no, I think it's yeah. I think it's not really important. And so yeah, I I mean, so which machine is this? Actually, it's IQ. Oh, it is IQ IQ Video Studio. So yeah, you can find a lot of I mean a lot. There's a few of those processor which are kind of simple. They usually come with the audio part, and yeah, it's yeah really basic, but yeah, it's quite a good a good way to start, because there is also I got a simpler one. Uh, this is AMA video mixer, for example, this one, and you only got enhance and fade. So it's it's more simple in how it works, and so the more complex sorry, the more complex the device, usually the more complex the effect you can get, but also the more it can be it can be harder to bend because the circuit is bigger. I mean, you can do circuit bending is all about experimenting also. So yeah, I think it's good to understand part of the circuit, but it's also good to like try stuff and just learn along the. So yeah, let's get back to data sheets. So yeah, the chip here is N NJM 220. Oh shit. Yeah, I was in query to play the Fubar Expo game. So we got NGM 2209S. So it's the only really dedicated chip, video chip in the circuit. Sometimes it's replaced by a few transistor and some other components, but I've seen this one in a few of the chip enhancer device, and so yeah, we can have the pin out, so we can know like what each pin does, and so yeah, you got video signal input, video signal output, 9 control input. We can see. I think it's here. Yeah, they show how it's the gain fader. It's this one. Yeah, it's a bit annoying because yeah, it's the one that oh yeah, I don't have this anymore. So yeah, it acts on the contrast, and so yeah, it can be. We can see here that is done. Oh, sorry. So yeah, it's yeah, we can have basically all the information about the chips, and yeah, also about like more complex digital device. Yeah, usually like for example Panasonic, they use really specific chips, so sometimes you cannot find the data sheets. It's like they were doing, sometimes they were like custom chips, and so yeah, it's sometimes it's a bit hard to find documentation about it, and yeah, sometimes it's better to check the service manual and just try to guess stuff by the schematic, but yeah. So yeah, this is this one is an interesting chip because it processed the video, and so we know we can do stuff around this one, and yeah. So yeah, let's move on to other stuff on the circuits. How do you sorry, I just seen your comment. How do you identify and trace the main? So how do you identify trace the main? Actually, here is there's no main since it's directly a wall wart. But yeah, usually you can see it on the PCB. Usually they will isolate. You can see on the trace. They usually isolate the main AC part and the regulated part. And so, but yeah, it's yeah. I mean, if yeah yeah, then you can use also a digital voltmeter like I use, and you can like try measuring and following the input. But yeah, I would not recommend working with the mains with something that is plugged to main. Uh, do you think it's possible to change an audio input into a video input on this kind of circuit? Yeah, actually, it's something you can do, and so you can reuse the audio part, and so but yeah, then again, it's you need to like trying to see what will be the best way to do it. But yeah, actually, since you got the audio coming in, it maybe it's a bit amplified. and you should be able. Now, maybe the easiest way to find it on the circuit would be to plug like a cheap speaker with a jack and just like try to find the audio signal and then just like plug it the to the video part. But I will show you after maybe how we can interface audio stuff and yeah. It is possible to repurpose the audio faders bars into video function. Actually, I was thinking about this, but it depends because I will talk about it a bit later when I start doing the mods. But it's usually good to use a low value potentiometer. Like I use one kilo ohms, because yeah the it seems that the glitch and stuff happens at really low resistance value. And so yeah, I prefer to use 1K because it gives a good range. If you use a bigger value, sometimes you will only have like effect at the end of the range. That was the issue with the first version of the AV mod. It's like the potentiometer act like a switch, more like a switch than a potentiometer. And so yeah, and why I was saying this, it's usually in audio that we use bigger value. And for example, here we can, it's readable, but for example, the fader used for the audio fade is I don't know how readable it will be in the stream, but yeah, here you got 100k hey, so 100k is the value of the fader. A is the curve. In audio, A is logarithmic. In audio, you usually use logarithmic potentiometer, and yeah, for other purpose, it's usually linear. And you got like x2 because it's there's two fader, there's two potentiometer in one. I think you with the by activating the actuator here, you actually have two potentiometer. So because yeah, because it's stereo, you need to fade left and right at the same time. But you can use them. It will just be, maybe it will be a bit yeah, acting like a switch, so only on the end of the range. So, but yeah, it can be repurposed, or you can also try to put a resistor across the potentiometer if the value is too high and it doesn't really much. And but yeah, actually it will the potentiometer will not be linear anymore, but it can also be a way to drop the potentiometer value to have like a more usable range. So yeah, just need to cut the trace of the fader going to audio and then just rewire them to the video part. Oh yeah, Tim. One way is to cut the trace on the audio faders and we rewire them main points on the circuit. Yeah, exactly. So yeah. So yeah, we can move on a bit. Also, one thing you can do to find so yeah. So so for example, you got for the to identify stuff. Here we got trimmer potentiometer. So there are potentiometer that are meant to be set and not moved by the user actually. And yeah, it's a good way to understand what it does. And here, I don't know if it's really visible. For example, this is the potentiometers. Oh, I shorted the pot and it did some glitch. So yeah, this is a potentiometer, and I already know what they will do because just next to it you got yeah, it's upside down. Yeah, it's yeah, those are monostable. The chip, they are 4538, and I can, yeah, maybe I don't know if it's worth checking it, but it's often used in circuits to do, for example, yeah, I'll give you the the answer now. And yeah, so we got a split screen function. So you can see the left part of the screen is our source video, and the right part is the processed video. And so basically, this potentiometer, the probably act on the how can I say the wipe the vertical position of the split screen. So yeah, maybe it can be interesting to move. Also, yeah, maybe here they're using like a kind of paint on the trimmer to, like, I think, hold them in place so it doesn't move, and also it indicates how it was set. But it's good to like take pictures or stuff before you're moving them, because sometimes stuff, yeah, you don't really know how to set it back. So yeah, I don't know what this one does. Oh yeah, I can adjust the length of the the split screen, so it, yeah, so screen. So and we got some glitch a bit. So yeah, you could like have them in a have them rewired at the panel and mess with it if this is something you want. Because yeah, you can also change the capacitor value, and it is change the range of the range of the screen, like the and you can see. And the last one, I think it's not used for the split screen, but it must be used for the circuit to work properly. Let's check. Oh no, oh, okay, it's yeah, it's probably vertical banking. Yeah, because it's, yeah, you can see it moved at the bottom. So probably. So yeah, this is yeah, this you can also search band around them, because yeah, they are used sometimes to switch between the input signal and the output signal, and so yeah, you can mess with them and it can be interesting, I think. Mm, so yeah, and yeah, the last chip we can check is this one. So this is a 4053. So yeah, it's the same family as the previous one we've seen, but those one are switches. So they usually used to route the signal, like from the input or the output. And for example, the split screen is probably one of those switch that switches between the inputs to let it to the right part, to the left part. Oh, I'm just starting the camera again. So yeah, this is the original video. So probably this switch will like say, hey, during the first half of the screen, let the input signal goes directly to the output, so we can see the input signal. And so yeah, so maybe if I start just messing with it, you probably do stuff. I don't know. Don't do this. No, joking. Yeah, it's better not to not to do direct connection between the band point you want to do, because that's where you can start like burning stuff, because you can draw a lot of current. For example, if you're taking the supply pin, the power supply, the 8 volts that is powering the whole circuit, and you put it to the ground, the regulator might not really like. And so yeah, you were talking about someone was talking about tracing the main, and yeah, actually you can, if you are really willing to do it, you can trace, or at least test with your multimeter and check like which points are the power supply, and identify them and try to avoid them, because usually there's not much to do, like beside active circuit that will do stuff. There's not much interest in connecting stuff from the 8 volt power supply here. Um, so yeah, and I didn't really talk about, oh, there's still those two, and yeah, there's still those two chips at the top that are probably used for video. Oh yeah, 46.6, it's switch also, and yeah, the same as the other one, 505, 4, sorry, 4053. So yeah, actually, and they're all the transistor are also used for the video part, but it's, yeah, it will be a bit long to explain it, I think, and it needed a lot of tracing underneath, and I mean, checking, yeah, where the signal goes, and yeah, it can be a bit long if you want to understand the circuit. That's why, yeah, it's good to have access to a schematic sometime to understand the circuit a bit. So yeah, another thing I didn't show. This is, yeah. So we've seen just before, we've seen those trimmer potentiometers, those one. So they are variable resistor, like the fader, like the value of the resistor between the resistor. Actually there are three pins, but yeah, it's a variable resistor. And we also have a variable capacitor. So yeah, this is the little green thing here. And yeah, in those circuits, if the circuit is processing processing color, so you can see here it's oh no, you cannot see because it zoomed. The zoom. So yeah, since it processed the color, you need the issue with composite video. If I go back to our signal, so yeah, the issue with the composite video, and that's where the name composite comes from, is the fact that color is encoded with the black and white information. And so to process color separately from the rest of the video, you need to extract, like separate those two component of the. I will not use a component because it's it can be, yeah, it's another video standard, but yeah, you got two parts, and you got to separate those two parts of the video, and that's why the S video format is for, you got Luma, which is the black and white information, which is separated from chroma, which is color. And so here the circuit does the separation, and it's actually there's a filter that does the separation, and it's set with this little trimmer, capacitor trimmer, and I will show you right now. So for example, here I've cut the color. That's crazy how the EasyCap just take whatever you send into and just boost the color, even if there's not anymore. And so yeah, if I start messing with it, you will see that, yeah, it like set the frequency for the filter, and so if I move it, yeah, we're getting colors back. So yeah, it should be set for the minimal uh, color picture in the end picture, but you cannot. It's hard to set it so it doesn't pick up any color. So yeah. Oh, okay. This was the boring part. So yeah, this is the, yeah. This it's good to, like, yeah, try to find some info about the circuit, and it will help you like find the part where to test stuff. Like for more complex circuit, it's good like to identify the different part. I'm thinking a lot of digital video mixer because a lot of people want to bend them, but they are quite complex, and yeah, it's good to identify the different part, like the CPU, the RAM, video, DAC, ADCs, and stuff like that. And yeah, it's so yeah, better try with the small circuits. So yeah, let me drink a bit. What was the video signal called before they added color to it? I don't know if it was already. Let me do a quick check. I know because maybe composite is also the name for the Oh no, because yeah, CVBS is actually composite video blanking synchro sync, so it's yeah, it doesn't. I mean the yeah, that's something. Good question, Tim. I really don't know. Yeah, what the because yeah, composite it doesn't mention the yeah. Good question. I will search about it and and yeah. So yeah, let's start like bending, actual bending. So so little breadboard. So yeah, as I said before, it's good to not do direct connection between stuff. Like I will be using those alligator clips. So yeah, it's usually not really direct connection between stuff because that's where yeah you might burn a ship or or something. So yeah, um, like so how yeah how glitch usually works. So analog glitch, I mean it's based a lot on feedback loop. So like taking the output, taking it back to the input, and so yeah, something really basic you can do. Getting so here I got a capacitor. I don't know 4.7 nanofarads, and it's a film one. The technology the like this is a film capacitor. Here I got a ceramic one, and yeah, it doesn't really matter much. I think audio film capacitor are more used in audio. I still have them from when I was doing audio stuff. But yeah, you can see here there's like mixed. There is like those one are film capacitor, those one are ceramic, and yeah, there's not much difference between them. I mean, for video, there probably are if they use different one here, but yeah. So yeah, one quick thing you can do is like taking a capacitor and just put it between the two, between the outputs and the input. Uh, doesn't do anything, right? So yeah, we just changed the yeah face generated with the this person doesn't exist. so so yeah, we don't have much going on, and maybe we can try change the capacitor value. Oh, what's the 100 farads? Oh yeah, okay, it wasn't making contact. So yeah, we got feedback now, and yeah, you can see the scope isn't syncing anymore because we can we're messing directly with the video input, and so yeah, it cannot sync to it. But yeah, and then usually you can like adjust stuff. Oh yeah, I don't know if we create. Yeah, we can't really see the input and output part. But yeah, I've plugged like one of the one of the alligator clip to the input, the other one to the output, and I got a capacitor in between. And yeah, you can see it started messing with the, like, blurring the picture at first, and then yeah, it starts oscillating and messing with the colors. So yeah, and yeah, then you can add like a potentiometer to so yeah, basically I will put my, can we see it a bit? So yeah, I got a capacitor here. So yeah, then you can put a potentiometer in between. So yeah, it goes like input goes to the capacitor, then the other leg of the capacitor goes to the outer leg of the potentiometer, and then I can plug the other way, the other wire that is plugged to the output of the circuits to the middle pin of the potentiometer. Then I should be able to have the effect attenuated with the potentiometer. So yeah, then you can try to change the capacitor value, and really it will target other frequency, because yeah, I was talking about feedback loops. So here we're like taking the outputs, sending it to the capacitor and the potentiometer, and then back to the inputs. And what we're doing with the capacitor and the potentiometer is a filter. So basically we have taking the signal at the output, filtering it, and sending it back the to the outputs. And I can try just to plug the input to the output, but they just, oh no, it's fine. Maybe there's a bit of capacitance in the, yeah, like direct feedback between output and the input. But yeah, usually it's better to take the signal not directly to the RCA sockets. Which size of potentiometer? 1K? Yeah, yeah, I use 1K here. Yeah, I can show you. Uh, yep, 1K, B for beta. It's the curve of the potentiometer. As I said before, A are for audio, so yeah, it's might not be. Uh, I mean, it will work anyway with the logarithmic one, but the curve will be maybe a bit. Yeah, it's circuit bending. It's, yeah, just use what you have. Yeah, because I can show you with the, maybe with the 10K potentiometer. I need to plug this back here. Yeah, let me grab 10K. I think here. So yeah, as you can see, I don't know. Yeah, it really starts of the potentiometer, and yeah, for almost like a third of the range, you don't have anything going on. So that's why I prefer to use like 1K, because the broader range with the signal. Yeah, not that much actually. As you can see, it's really just on the end. But that's why, yeah, it's good to adjust and just change the capacitor. We put the lower value. So yeah, but yeah, as you can see, it's, yeah, really on the end of the potentiometer range that it starts to get interesting. So yeah. So yeah, with the, I mean, usually you have something nice with the by plugging the output to the inputs. Yeah, let's start messing. And yeah, what I suggest when you're searching band points, it's connected to somewhere you know there is video. For example, I would just keep one to the output of the circuit. Just this. Oh yeah, I will keep this one here at the outputs, and yeah, try to yeah mess with the circuit. So yeah, so for example, I know I've got power somewhere around here. So yeah, just avoid doing stuff with power because it's not interesting. For example, we've seen that this chip is a video enhancer, so I think it's interesting to check what's going on around it. So yeah, just playing plug stuff. Yeah, yeah, the edge feedback. So yeah, since the this part only process the black and white video, I think we won't have much with the colors and stuff. So it's more black and white kind of feedback. Maybe I can try putting a bigger capacitor. See, but yeah, no, it's more intense. And yeah, usually for the capacitor, the lower the value, usually the more it will mess with the high-end details and colors and stuff because it reaches higher frequencies. And yeah, usually big value caps like electrolytic caps, for example. Let me grab one, some laying around here. Like for example, yeah, we have plenty on the board, but those cylindrical caps, and yeah, those one are big values, and usually I experience um, more seeing distortions and stuff with bigger caps because I think it's like a lower filtering value, and so you might send back stuff in the lower frequency, and this is where the sync signal is, and so yeah, usually it's good to try with different capacitor value to see how it reacts. So yeah, let's try other point of the circuit. For example, we were saying that this one is messing with the color, so maybe it's interesting to try stuff around it. So this is a bit. So yeah, for example, if I got like a really shaking effect like this, it's good to quick check with the multimeter. Um, like yeah, just to be sure I'm not like power supply. So yeah, just check that it's not the power. It's 3.4, so our power is 8 volt here. So yeah, no, so okay to like plug it here. Yeah, that's missing the colors. Nice. Oh, that's nice. It does kind of elongated stuff on the CRT. Interesting. Can you have something a bit more stable? Maybe I should try with the smaller cap value just to see. And yeah, basically all time you need to have capacitor and potentiometer when making circuit bending. Yeah, it's good to have like at least because actually you can try just with the resistor. I think it's yeah. Oh, it's even here. It's even more interesting. But yeah, at least you want something in between, like a potentiometer, and yeah, it actually look better without the capacitor here. So you just want to have something in between, as because yeah, direct connection we can try it here, but yeah, usually if the pictures goes black like this, yeah, it's better not to, yeah, because yeah, you're doing direct connection, so it's easier to lose the signal, and maybe it will like draw a bit too much current, and yeah, the circuit will not like it. So usually better to have something in between, and even a potentiometer when it's like when both hands are connected, there's still a bit of resistance, but yeah, it's really good to have something in between your your bend points. So yeah, let's put some cap back. I really like this one. Maybe you can. Yeah, no, it's. I've set it back. Hello is all the time at video out. Yeah. I kept it on video out because yeah, it's actually what you want to do with the feedback path you create with the potentiometer and here the capacitor is to be in between 2 points that carries video, because on the circuit we have ground, you have the power supply, and you also have like control signals and stuff that are not video. So you want to try to find a point where you got video. So that's why, since you got two variables, since you got the 2 points of the two main points, it's good to have like one is video, and the other one you just like travel around the circuit and just like touch stuff and see if you can get something interesting. And here, but its potentiometer is way up. So yeah, for example, this was related to, I think, vertical banking. Oh, yeah, just. So yeah, usually if the pictures goes black directly, just like yeah, probably not a good bend point, or might be like definitive, because yeah, that's also something you probably want is the effect to be reversible, like to be able to go back to a normal picture. And so yeah, it's depends of the bend points, but yeah, it's better to have something. Yeah, if the picture go to black, you either drawing too much current out of the power supply, or even just shorting the output to a ground. So it's not really good. So yeah, after we can just like, for example, this point was interesting, so maybe I can try like touching somewhere else. Yeah, this one. But yeah, then once you find something as an effect you like, yeah, it's a bit too much here. And yeah, you just like take some wire and strip the wire and solder the points. I prefer, we'll see the other side of the board after, but I prefer to work from this side because I can see like all the component and stuff, because on the other side it's a bit of a mess with all the traces and stuff. Can be a bit overwhelming. So yeah, but for example, for the chips and stuff, you need to tape the point on the bottom of the circuit. So yeah, this one isn't hyper interesting. So yeah, one thing you can do also is take notes as long as you try stuff and say, oh, this one is cool, I want to keep it. And so yeah, so you can like try stuff and go back to it afterwards. Because yeah, also there will be a lot of interaction between like two effects, two glitch effect, because yeah, the first one, since there are like loops, like anything that is fed back to the circuit will also be affected by the other one. And yeah, so that really complex feedback system. So yeah. Oh, I was changing the cap. But yeah, no, this one is a bit too much for me, for my taste. Yeah. Oh, yeah, nice. It does a kind of phase shift. No, it doesn't fit much on the capture card. Oh yeah, also I didn't really talk about this, but yeah, the capture card is easy cap, and quite those one takes glitch pretty well, so you can really like mess with the signal without really worrying for it to drop. And the TV I'm filming on is a Sony PVM, so it really requires the signal to be in spec to display a proper picture here. It's really too glitch to show the thing. So the TV will probably drop more than the capture card, which is a bit weird because it's usually the opposite. But it's handy to test the circuit when you want them to work properly first and then start thing with them. Yeah, this one is auto cap. Yeah, it's good to test with the cap. And so yeah, thing we can interesting thing we can try. Let's come. Yep. So those are LDR. LDR. So they are light dependent resistor. So it's a resistor in which the value will change with the intensity of light, and so we can use it to I can put it either at the where my potentiometer was. So maybe the value will not be really good, but we should have something works. Maybe more light here. It's not really. Maybe with the potentiometer in parallel. Does it? I don't know if this one is toast. I just touch. But yeah, maybe with the if I plug it. Oh yeah, it works a bit better here. But yeah, you can have like audio, video. What do I say? Light reactive glitch effect. So yeah, the more light I will put into it, and here the more the effect will be pronounced. I move this, and it's not really focused anymore. Sorry for all the technical issues. Like the first time I do this, so there's a lot to learn. So yeah, the light dependent resistor is here, and so yeah, once I move my hand and the other screen, so yeah, it's changed the effect change where my easy cap represent. Yeah, easy cap. So yeah, this can be like a way to interface with the machine, and yeah, you can also like fingers are a good way to stuff also, because the like the finger will have like a capacitance, so maybe even just touching stuff, yeah, like this, for example, I know BPMC it really likes to put body contacts, and it's really interesting because your body is just a big capacitor, and so you can yeah just do like this. Nice. So yeah, then about so yeah, maybe I can just show a few way. So yeah, there's a way to implement, for example, audio reactivity, and usually you can use the LDR with just in for. What is the resistor called that use body contact making mouse all this? I think there's two different thing. I was doing like the body contact is I will just go back to this and so yeah, the body contact was just like the two. I use alligator clips because it's easier to clip to stuff, but you can use like just plain wires, and yeah, having like touching the same with the finger is enough sometime to just start messing with signal, and so the other one the one this is the LDR, the light dependent resistor, and so this one is light reactive, so it will change depending of the light you got in front of it. And yeah, you can probably find them from Mauser, but I know they are done with a cadmium sulfide or something like that. It's like they're doing newer ones now. So but yeah, I think I got them from Taida, which is a Thailand-based component supplier, and yeah, they're quite cheap, and you can get stuff in small quantities, whereas without having to order for like a 50 euro like Mauser. So yeah, that's also a good way. But you can find them under the name LDR or light dependent resistor. And yeah. So yeah, maybe I can just show you a few ways to control to control the circuit with an external signal. And so um, you can, for example, the AV mode. Uh, so yeah, for example, the AV mode uses the the LDR we've seen before. Oh yeah, we can try my mouse. It's the same component as we used before is LDR, so light dependent resistor, and you can couple it with a diode, LED and light emitting diode, and so the audio you send to the LED will change I mean the audio will. For example, audio will make the LED light up or shut down, and depending of the light intensity, the LDR would change in value. So that's a way to implement like activity, for example. So yeah, the issue is that usually you need the resistor, the diode, the direct audio isn't enough sometimes to line audio, for example, from your phone or your laptop is sometimes not enough to drive a LED, so LED. So you need some amplifier or some sort before to make it work. And yeah, another way to do your reactivity or TV control is JFETs. Those are um, family of transistor, and they can be used as a voltage control resistor in some instance. So yeah, for example, you got here simple attenuator circuits, and yeah, this is a way you can here have, for example, the only thing that is annoying with this solution is that the transistor, the GFET, needs a path to ground somewhere. So it needs to be tied between ground and something. But you could have, like, for example, here one of your band point here and another one here. And depending of the voltage, for example, audio or something you send to this part of the transistor here, you have attenuation depending of the signal here. So it can be implemented like this, but yeah, usually it's a bit complicated sometimes because yeah, it's yeah, you need also, like for the LED, you might need to have some offset input, and yeah, it can be being, and yeah, and then you can also try to input audio directly to the without anything in between. I mean, just best is to, or at least like 1K or some resistor in between your output and the circuit to stuff. So it's can be done also like this. It's not the best way. It's better to have something to isolate either LED, because the back to the AV mathematics, the advantage of the circuit is it's called the couple of the LDR and the LED. They are called opto isolator or optocoupler, and so the interesting thing is that it's electrically isolated from the I mean the diode here. It's here they are on the same circuit, but diode here and connected electrically to the LDR, and so it's a way to these two different circuit without having to mess with having the same power or like that. So yeah. So maybe I can go back to the chat and have some questions if anyone wants to ask question. Yeah. Back to how we need